Welcome, welcome, welcome. I hope you're as excited as I am. It's Wireless Tuesday. Wireless Tuesday is a monthly podcast that revolves around Cisco wireless LAN and related technologies. It's a way for me and my colleagues on the Cisco Global Wireless team to give back to the community that's given us so much. My name is Jason Grant, and I'm your host. Let's get it going. It's Wireless Tuesday. Thanks so much for joining us on Wireless Tuesday. It is, again, my favorite day of the month. With me today is Min-Se Kim. Min-Se is not quite as far away from me right now as you could get. Min-Se, where are you today?
Yeah, today I'm in one of the fevers of the football game that happened yesterday. We had a game to the Germany and had an interesting night. Yeah, I'm in Seoul, Korea.
Seoul, Korea. So soccer aside, football aside, how's your trip going?
Oh yeah, that trip going well. I met a couple of customers here and met all these partners and theoretical partner. They all seems to be excited on the new offer from Cisco, DNA assurance and all the new use cases that we are delivering. Yeah, so it's all good, wonderful days.
Well, that's great. Now, you're not normally in Seoul. Where is home normally for you?
Yeah, I used to live in Seoul until I get 30, but right now I'm living in U.S.
Cool. Now, and you're based out of San Jose.
Yeah.
And you're a technical marketing engineer or a senior technical marketing engineer. And you focus only on DNA assurance, right? Or wireless assurance even, right?
Right. I'm only doing the DNA wireless assurance. So more specifically, yeah, we have lots of things to do on the DNA wireless assurance. There are lots of customer demand. Yeah, so there are lots of things to do on my daytime and even nighttime.
Yeah, I can imagine. And being there, you probably have to deal with West Coast U.S. time and Seoul time, which doesn't always jive up very well, I can imagine. So why does Cisco delineate assurance for wireless and for wired? Why isn't it just assurance?
Yeah. Well, in fact, if I look at the kind of a use case that I can solve from the assurance point of view, I don't think there is a kind of a strict delineation between the wireless and wired use case. Like we have a case where can handle the wired and wireless in the exact same manners from the workflow of troubleshooting, such as a path trace and the topology views and the client 360. But the one thing that I found was there are a bit of different types of clients or different types of onboarding behavior between the two devices. For example, when we deal with the wired, everything is so clear. It's more like a black and white. Once I get the connectivity, connectivity is usually easily done because there is the medium like a cabling. But in wireless, the mediums and the quality of experience for each end user is usually different by their location and time and the other external elements such as interferences and some neighbors usages. So we found was wireless customers struggle a little further than a wired user to identify their experience, to identify the root cause of the problem. So Cisco decided to put a little more effort on the wireless side so that wireless user can have a similar experience as a wired as what they used to have, not only as an end user point of view, but also as the troubleshooting point of view. Like example, maybe I spent too much time. Okay, Jason.
Oh, no, that's great. I really appreciate it. That makes sense. Because what I heard you say was, as far as assurance is concerned, they're really not different, wired and wireless. The difference, or what differentiates, is the fact that wireless is a whole lot more difficult, a whole lot more extensive troubleshooting techniques, and that's what you're focusing on.
Exactly.
Cool. Well, I know that since we talked about DNA assurance last on Wireless Tuesday, a lot has been introduced. A lot has changed in terms of capabilities. Why don't you take us through a little bit what's changed and what we can use assurance for? Would you do that for us?
Oh yeah, absolutely, Jason. So DNA wireless assurance is a part of a DNA Center packages. So DNA Center is the one holy grail of enterprise networking management console that is starting from the day zero PMP, day one deployments and installations, and especially assurance part focusing on the day-to-day management as well as troubleshooting. And the more and more people uses the DNA Center, often they found that they spend more time on the assurance because there's a no end date of operation. Operation is continually going on until they have a new design and migration. So usually it can go, 3 years, 7 years, and throughout the life cycles of management, they have to have a better way to identify their network performance and a better way to pick up the specific part of the problem that causing a bit of a suboptimal experience on the end user or network services. And then to get that, to deliver those use cases, we went through the series of the customer interviews as well as we collect all the Cisco expertise on the operation side as well as our feature side and the product side, and we found that the three key requirement has to be delivered to solve this requirement. First one was providing a better context. Better context is something that we're never able to deliver. So we just talk about the wireless user, that how wireless user is different from wired user. In wireless user, there is some unique parts of the execution has to happen on the networking level, which they before they join the network, before they actually able to use their network. That is Wi-Fi onboarding, and Wi-Fi onboarding is like 8 or 10 different steps. Wait a minute. 8 or 10 different steps, such as the authentications and the association and DHCPs and different key exchanges, scannings and roaming. This type of extra steps has been hidden from the traditional networking management tool. So which actually make us harder to troubleshoot the wireless experiences. That's why we are adding at the DNA assurance as a right place, which is right context. And the right time, probably this is the most typical symptoms of Wi-Fi, that Wi-Fi problem is not really a permanent issue. It's rather is a transient issue. The issues can happen 10 times per day, but it's probably 10 seconds of the disconnection that happen throughout the day. So the customer might have frustration because he had so much of a disconnection during their the conference call, but because it was so intermittent, it was difficult to when you grab that specific moments. And then when customer report their problem, the whole environment that tag or their support the user need to collect can be completely different. Even though the user is just standing on the same location and the same AP, who knows? And there's no guarantee that my device connecting the same AP as yesterday. So this kind of problem makes us a little difficult to capture. To get this solved, we have to collect all the information all the time without sacrificing the granularity of information. And then we also have to get this fixed or monitored proactively. So even before any end user hit this kind of a symptom, the system have to able to predict which area can be possibly more problematic compared to other locations, so that we can predict what's coming in the Tuesday 8 a.m. when the board meeting happens. As a third way is the right actions, and what we added recently as a right actions is adding the forensic on top of our insight and guided remediation, because we discussed about the issue detection and correlation in the previous episode of the Wireless Tuesday, and then one thing that we had to prepare to persuade the other guy. Let's say that my Wi-Fi problem, is caused by not my AP, but from elsewhere. What if the system point out the client devices as a root cause of a problem? Then usual issue detection and the guided remediation have to have a right forensic to persuade my counterpart. And that's usually the packet capture that we've been using for the last 30 years, 20 years at minimum, right? Take a packet captures and highlight the specific, the erratic handshake sequence. Hence, you have solved this problem. It's your problem, buddy. So that part has been a standard exercise of any troubleshooting, regardless of a wired or wireless. The one thing that we didn't have was we didn't have equivalent features on the wireless, such as, have you heard about the wireless ERS span? You probably never heard about that, right?
So what is that?
Yeah, there's no such things. That's the problem. In the wired world, we have a port mirroring, and we can do a port mirroring in the switch that's sitting in front of me, but I can do a port mirror from the far away place, right? There's a remote span, the extended the remote span port. So we can capture at anywhere in the wired world. Right. But if you just switch the gear to wireless, can you capture the packets at any time in the 1,000 miles away? Usually it's not. Usually we have to dispatch the guy. You have to staging the packet capture environments. And probably we have to wait like 8 hours because we don't know that when the symptom recreated, because it looks all random. And then this requires lots of pre and post exercise to actually analyze the symptoms of the end user. So those things has to be added as a part of issue detection and insight and guided remediation, so that we can take the action with the evidence. And without evidence, who will believe the issue detection, right? So these bring us a lot of more powerful capability in the DNA assurance. Now we have an ability to keep track every single user's the onboarding steps, which come into the 240 different stages. I think this was mentioned in the previous episode. So I will show you all these the actual events and the forensic in the following section on the demo time. That's
great.
All right. So here's the features that we can go over on the DNA Assurance 1.2. Probably we have to spend like 3 hours or 4 hours to go over all the feature set, but it's probably not what we want to do. So for this episode, I want to focus on the one most interesting topic that Cisco is going to be released the next month, which we call the intelligent capture. So intelligent capture is the function that Cisco announced in the partner connection week in the 2 months ago. But we had the demo to the public audience in a couple of weeks ago in the Cisco Live last month. So it was presented and demoed live by David Gekulas and Sachin Gupta, who is the EVP of the Cisco Development Organization. And then the 16,000 audience and together with the online user, 25,000 users has been experienced how much we can enhance as a practice of wireless troubleshooting, and as enhanced visibility of Wi-Fi in the user operations, and then and ended up what we tried to solve was the the abstract or compressed the time to resolve in the 72 hours to just merely a few minutes. It's pretty significant. We used to took at least 1 or 2 weeks to solve the Wi-Fi problem that has been like industry standard. But now the pull 8 days and 10 days of the Wi-Fi troubleshooting went down to 30 minutes and few minutes. And I will show you that how we can solve that, get down to that, how we can achieve such a huge kind of enhancement of troubleshooting in the demonstration.
So let me stop you, Mincy, real quick. Can you go back one slide for me, please? I love this slide because what it does is it helps me understand what DNA assurance can do, right? I'm having a problem onboarding a client. Well, DNA assurance has the ability to go and look at all of the aspects of onboarding and tell you what aspect is not working or is slow or what the problem is. Client and network experience is a use case. I get that. Sensor-based monitoring. I love that. I saw that at Cisco Live. I was fortunate enough to go to Cisco Live. I actually got to see some of these sensors working right there on the floor. We could actually look at people's phones right on the floor as the demonstration. Let's look at my device. And then application experience. Yeah, everybody has been there when my application hasn't been working right. But you said something that I want to just underscore. So if you go to that next slide, what you're saying is today we have all of that. And in the very next release that we're going to come out with, just when this says tomorrow, I'm pretty sure it's not tomorrow. When is this next release due?
Yeah, we are working very hard. We're very hard to release this software, and we are targeting the end of summer as our the next.
What I'm reading here is something that's really interesting, right? Live client onboarding state, anomaly-based packet captures, on-demand RF scanning, real-time client location, and on-demand Wi-Fi and application analytics. Is that what you can show me right now?
Oh yeah, absolutely.
I want to see that, especially see the packet captures that I don't have to go and initiate, but rather were initiated because an anomaly was to be detected. I'm skeptical, so sell me, Minsei.
Absolutely, yeah. So let's start some magic. Okay, let's switch the app to my browser, and if I can make it larger. Yep. So here's a typical wireless assurance screen, and you might find it slightly different because this is the latest DNA assurance we haven't exposed to the world yet. So this is the UI of the next version of DNA assurance. And then it indicates that there is some wireless users may have a difficulty to join my networks, or at least it's a suboptimal because my wireless clients are showing 80% not in the 100%. I mean, there's a network percentages which shows a different number, but let me skip the network part and let's focus on the wireless client for today's. And then here is the new client health pages. And you can see that there is the health score trending, which we call a sparkling chart, that's showing the trend of the last 24 hours. But consistently, I have a wireless health score which is 80s, and there's a one client showing as a poor, and 4 of them in the good conditions. So what does that mean? In the summary view, you can clearly see that how that segregation or segmentation is going on. So I have a total 5 active clients, and one of them is failing to onboard. 4 of them passes the onboarding step, so they are in the good condition, at least from the audit point of view. But I need to know that what is going on this one user. So if I scroll further, there's a client detail for last 5 minutes, and then there's the guy like a Richard, Benkats, and Marios, and Cisco's looks all good, but there's one client, June, have 000s as their IP addresses, and the overall health is 1. It's not a 10. We can clearly see that something is going on this client. So let's zoom in on this client June, and here's the client June's the screen. Like you can see, I can see that the client location here, the client is joined on the AP4 right now. I see a line here, and then looks like RF is somewhat in the middle between the AP4 and AP1, but I don't think that this client have an RF problem. Let me see that if the client have any RF problem by clicking the summary view, and then it wrote the current location of the client. That's why that it says as a real-time client. While the pages get loaded, let's go into the RF stat, right? This is RF stat of a client. You might not be able to see it clearly, but there is the stats being gathered, like a 54 as their SNR is extremely high. RSSI is neg 41. So with this level of RF, I cannot say that this is RF problem, right? It's a rather extremely strong signal in the general practice of Wi-Fi, right? But clients are still having a problem. So let me click any red event. These are the onboarding events that happens on these users, right? And then it says that my DHCP is being failed. So if I scroll down further, there is an auto packet analyzer, and it shows that what has happened on this user in terms of the onboarding steps. The onboarding step starts from the proving to authentication. It'll start open authentication and the association request, response, EAP, key exchanges, DHCP, and data transmission, right? The 6 stages of a total Wi-Fi process of onboarding. And from this step, the step goes from the 4th step to a 5th and last data packet. But you can see that there's a few strange things going on this chart. First, why my DHCP is having just a one-directional, unidirectional conversation? How we know that this is unidirectional? Because each triangle have a different shape between the client AP packet to AP to client packet. And the client AP packets is coming all from the client to the network, DHCP, but there is no reply, there's no response from the network. Hence, my AP have to disconnect this user because obviously there's a deadlock condition. And if you look at the the latency or the time between each packet, for example, this DHCP packet number 19 and packet number 20 took almost 10 seconds, right? From this packet to this packet, like it took like almost 5 seconds and 10 seconds. So client really took a long time and trying really hard to finish the DHCP step, but ended up it couldn't finish it. Hence, I got disconnected. So the system have to dissociate this user. So these are the typical kind of behavior that happening in the Wi-Fi world. So if there is contentions or conflict going on between the client onboarding machine and the AP onboarding machine, somebody needs to disconnect that user so that they can restart the whole process again. And then this problem, if I want to explain to my server guy, network guy, or the counterpart, my counterpart will probably require packet capture so that they can take action, because this particular screen is the Cisco's UI view, but the UI view may not raw data. And the raw data is something that make people to take action. And that raw data is available in just one click away from this event viewer. And here's the application the data and key exchanges, DHCP discover happenings, and there's a multiple DHCP discover, and check out this DHCP discover time. It initially starts from the 0 seconds, 0.05 seconds, and the next one took a 3.5, and 8 seconds, and 17 seconds. So there was, total aggregated is how much time? It's almost 28 seconds. And then have to dissociate the user. Oh yeah, dissociation happens in the 24th second. So from the first discovery to my dissociation, it took the 24 seconds, 24.05 seconds. That's why it called as excessive time to onboard, but it's failed, right? It's failing, and to get this dissociation step, it took a long time. So this is the failure condition, very obvious and very clearly identify the problems here.
Yeah, if I could interrupt you for just 1 second. So Minsei, I heard you say something that is really interesting, and you pulled up a packet capture. You went from like a 100 level college course to like a 300 level college course.
Yeah.
Starting to talk about packet captures, because typically in the wireless world, when I'm grabbing some packets, I have to not only have an understanding of essentially what the problem might be, but where the problem is. And I need to get tools out there or turn one of my access points into a sensor, and then wait like I'm, in some sort of surveillance van waiting for the problem to happen. And then I'm going to have to sort through pages and pages and pages of packet captures. I'm noticing you're not doing that. How did this happen?
I'm not doing anything at all. So how it happened is, every time that the user bump into the onboarding problem, such as in this case, the DHCP, you know what, Jason? I will show you the magic screen here, because sometimes go a little one step deeper into the system can give us a right idea that what's happening on the networks. So this is a controller UI, which in normal case, most of the case, customer doesn't really even need to go into this UI, because the DNA is even automate the entire step that is happening here. And I went into the intelligent capture mode, and there is a section called the anomaly detections. And anomaly detections is the option that's triggering the automated PCAP, automates the packet capture at the AP level. And we simply put the timeout conditions on the DHCP and the Aerostar 1X authentication. So if the DHCP took too long to be done, or if the handshake spend too much time than it is the usual KPI, SLA, then AP is sending all those client packets that has been stored in the AP memory. So because Cisco AP can support 400 users, we have the link buffer for each end user. So APs are not sending every packet all the time. It kept it for the moment like a 10 seconds and 15 seconds. And when the client onboardings violates my threshold, my SLA threshold, then a system sends that packets that is transmit and exchange it during this moment, so that I can automatically collect all these erratic onboarding on the packet that's happening on the end user side. And then if you're wondering that what is this onboarding packet, this is something like a new term, right? So what is the onboarding? Is it like a port number 64? Oh, you don't know, right? So that's where I define, we define this partial packet capture. And partial packet captures, we call the packet trace in the device world. So even in the one data type, there's a multiple data packet that we captured automatically. DHCP, ALP packet, DNS packet, EAP packet, and ISHB packet. Together with that, I capture the management, such as the association request response, authentication request response, and proof exchanges. So starting from the scanning toward the packet, it's been collected by the AP and sent it to DNA automatically. And the another beauty is all this UI you might find is a little more busy compared to the other, the controller UI. This entire UI being orchestrated by DNAC, so end user even doesn't need to go this screen. End user, what they will do is they are clicking from this screen. Oh, there's a red event going on. So let's check out what is happening. And they click to clients into the capture screen. And from here, I can identify my location. I can verify my RF stats and other conditions. And I can simply zoom down to the specific the moment that I had a problem. Let me say that I will zoom into these hours. And then system shows me that where I was at the time of 1 a.m., 1:21 a.m. This is the location on the last night 1 a.m. Actually this morning, early morning, and this is the packet exchanges that happened on that particular hours or minutes. And because the systems can send the data proactively in automated fashion, this is all I need to do. I don't need to know any single CLI or even GUI screen because I found that even the GUI screen sometimes it gets very messy. I have to know that which button, which screen that I have to click into, right, in the controller UI. But in the DNA world, even we don't need to do that. We just go by our intention. We think that, okay, I want to know detail. Let's check out what is there. And there's a blue text message, and I click it. Then it shows me the symptom that are happening. So although it was a university Wi-Fi college course of 300, I can do it. Even as end user level knowledge. I don't need to be expert to get the packet capture going and get the forensic data.
But and that's kind of my point, right? I don't need to be an expert per se, but maybe I understand what protocol decodes look like, and I don't now have to choose between a system that appears easy but isn't very capable versus a system that's very capable but very difficult to use. This is a little bit. It kind of is the best of both worlds. So that's great.
Exactly. Hey, Jason, I have another interesting client symptom that I actually discovered throughout this while I was making this demo. Do you want to go over one more case? Because I found that DHCP is a bit boring. Because, the DHCP is clear, right? This client not be able to connect. So it's either black or white. But there is a client who may have an intermittent disconnection. This client is a more interesting client from the troubleshooting exercise. And this client is always the case that has been a slippery client. So this is client, Mario, and the guy was purchased the latest and greatest Android, and then he connect the network. Wi-Fi is great, wonderful, Wave 2 AP, Wave 2 client, but this new device is somehow he's experiencing the intermittent disconnection while he was doing some text messaging. Sometimes the text messages over the Wi-Fi took a little longer. Sometimes the conference call, WebEx, or any different type of real-time application intermittently break up. Because endpoint saying that, you are not hearing. I wasn't able to hear for last 10 seconds. What's going on? That kind of things can happen quite often, in fact. And then if you see these clients on detail, this is a client 360 view. There's a true line going on. Top of the line, wow! Look at the top of the line. It's almost always the health score 10. Why is 10? Because check this out. This connectivity RSSI and SNR, huge, right? I have a 44 RSSI, absolutely great RSSI. But what is going on my bottom line? The bottom line, I see a lot of a red dot. And if we zoom in, this is actually red and green, vice versa, right? There's a lot of red event, a lot of green event. I don't know if it's an event or not. I just see a lot of red dots going on. So I have to know what is this red dot, right? If I scroll down a bit, it says that I have a few authentication failure condition, excessive time, but I really need to know what is going on in this excessive delay. And this is a new onboard event viewer. Check this out, so clear, right? I have a green event, which is onboarding. I have a red event, re-authentication. So in Wi-Fi world, there is a multiple different type of onboarding. Or the most typical is the just clean sheet onboarding. I just turn on my Wi-Fi, end user process entire steps of onboarding like a discovery and scan and authentication and DHCP. All went well, very smooth. But every few minutes, in fact, every 30 minutes of Cisco devices, or I mean, depends on the network configuration, but by default, the Aerostat 1X WPA2 enterprise session has to be renewed regularly, like every 30 minutes and every hours to keep our security level in maximum level. So every Wi-Fi does so-called re-authentication. And I can see that re-authentication is failing here. And due to a re-authentication failure, I'm having this the intermittent disconnection. It happens and get repeated over and over. And there's a broadcast key failing. There's other type of the renewal, session renewal, which is a group key renewal. This is also failing. So that's why I have a intermittent. Here's a success case. Here's a failure case. And what's the next step? We have to know that what is actually happening at the packet exchange level, right? Because this is a controller event. And let's say that I'm sending this controller event screen to device guy. Then what will happen? Do you think the device guy will, oh, Cisco, Mr. Cisco, yeah, I see a red dot here and say that it's a device problem. Let me check out. Do you think they will do that? Most of the case, they will say that, yeah, you know what? Can you send me a packet capture so that I can see more detail? That's typical interactions, right? So network troubleshooting can't step any forward without forensic, which is a packet capture in this case. And I can repeat the same exercise again. There's a client. Here's my location. There's RF stats. Let me get because I can get the correct RF stat at 2 a.m. So let me go back in time somewhere in the 2 a.m. And there's the failure condition. There's a red bar. Let me click the red one. IP ID timeout. And let's check out the packet. Now it's a bit interesting. It's getting interesting, right? Because exchange is different. There's a one IP ID request, IP OL key request, and then there's nothing going on from the client level. Then ended up, I have to deauthenticate the users. And then let's see what else that I'm seeing here. Here's a similar IP ID timeout. This time we didn't have a packet. Let's check out this client. Right? Again, similar condition. There is the data packet and one EAP and the authentication. Let's check out what is really going on the over the air wise. I download the packet and then launch it. So there's a bunch of ICMP, ALPs, the ICMP exchanges, and there's the identity request, but the authentication followed by that. So there is a re-authentication request initiated by AP because session renewal is the action from the AP. It's not an action from the device. It initiated by network, AP, and controller, and make client to respond to it, but there's no response. Hence, we declare this as a re-authentication failures, and the authentication comes as a result of the authentication failure.
So this is really spectacular that you can get this level of detail, and we can go back in time and not have to sit there waiting for it to happen, hoping I'm in the right place. at the right time. DNA Center Assurance does that for us. Let me ask you a question in this particular case, because this looks like one that would just be super frustrating to resolve, especially if it's happening to, like, you know, your boss or a director or someone who is like a VIP. What do you do to resolve this problem?
Yeah. So root cause of the problem is the client who does not know how to handle the authentication. So I think the root cause of the problem lies at the client level, because clients are not responding on the authentication request. So client need to check their supplicant, and they have to make certain changes and enhancements on the client. But usually that takes a little longer. So what we can do is check out the intervals of all the error. I can clearly see that there are lots of errors going on. Then this is usually goes by reauthentication. So one thing that we can try is changing the reauthentication interval. In fact, I accelerate the problem here because I changed the reauthentication window to 10 minutes. Every 10 minutes, client will do a reauthentication. Hence, I'm getting the reauthentication every 10 minutes. Intermittent disk problem accelerated by network configuration. So what we can do is check out, consult with the Wi-Fi security expert from Cisco's or Cisco partner, and ask what is the minimum session interval per single user. Well, Cisco's best practice, which is a default configuration, is a 30 minutes. So if we change the configuration to default value, then I can reduce the symptoms in the 1/3 of frequency compared to what I have here. But obviously, that's kind of a stopgap, right? Because client ended up, they have to change their configuration. I mean, they have to fix this problem at the client end. But identifying the root cause problem, that who is the bad guy, either clients or networks or servers or wired. I mean, once we identify the one specific part of my element, that alone will save tons of time to deliver the next step action.
I haven't really been a big sticker collector until recently, but I saw one at Cisco Live that I had to grab. It was a DNA Center Assurance sticker, and it said, the network isn't the problem and I can prove it. This is what we've done. We've proven, we see here that it's very clearly the client device that's misbehaving. But what you're suggesting is we can actually modify the network configuration so that it misbehaves a little bit less. We still have to address it, but maybe the impact to the user is a little bit less.
Mm-hmm. Then that's the part of the issue detail and the suggested action. Like what you can see here, client failed to connect due to what? Due to client timeout. Clients are not responding to my if ID request. So Cisco's assurance already identified this problem and already point out who is the bad guy on this particular junction. And then it provides the suggested action that what we can do with this. But one thing that we are not enabled, we have not enabled yet, is the config changes of my network. Because once we allow the system to modify their configuration dynamically, that has to be done in the very well-controlled the way, because there's always consequences and responsibility lies when we allow the machine to change my configurations, right? So right now we provide the suggested action, what we can do, but we are not actively kind of changing my network status. So I think that this is somewhat related with our philosophy, or related with our actual network operational policy. If we have a confidence on the automated network world, so that even we can rely on the machine to change their configuration to fix the current symptoms, probably it will require a bit of the time for the mutual trust right? This is the trust between me and my machine that goes all the way up to my management. So Cisco, we are working hard to increase the level of confidence and level of mutual trust. It's not really mutual. Only the customer need to trust the DNA assurance. And once we reach that level, I mean, who knows? This is an AI world, right? Do we have to rely on the machine to completely make control of my network or not? So I think that it will be an interesting next few years to kind of closed loop situation. We actually have all these and the connecting the dots, right? We connect the different dots from client, AP, and networks. But there's one remaining dot that's actually fixing the issues. But do you want the machine to fix issue by itself? So that's the interesting topic that maybe we can bring up in the next episode of Wireless Tuesday.
Oh, that would be great. You know, Min-Se, I really appreciate you taking time out of your schedule. It's the time change between the West Coast where I am and Seoul where you are is pretty extreme. So I really appreciate you taking some time. This has been really good. So we're actually looking at a little bit of crystal ball, right? We're looking into the crystal ball. This is what is going to be in the next release. Really, the only thing that we can't have today is intelligent capture. Now, I have a couple of questions for you. First of all, what access point do I need in order to do intelligent capture the way you've done it here? And what mode does it have to be in?
Great question. So intelligent capture is a software function that leverages the powers of Aeronet AP, in this case, Wave 2 AP. So any Aeronet AP that above 2800, 3800, 4800 will be able to exercise the benefit of intelligent capture. And the operational mode or deployment mode to enjoy this functionality is literally anything, any mode. So it runs on the local mode, Flex Connect mode, Mobility Express mode, and the Fabric Overlay mode, and FEW mode. In any mode, we support intelligent capture, same function and same benefit. The reason that we were able to get that is because we use the direct interface between the AP to DNAC. So AP get controlled by controller all the time, even the configuration part. But when it reports the symptoms to DNAC, it sends the information directly from AP to DNAC. AP create the separate the tunnel, which we call the gRPC, that leveraging the latest HTTP to the road transport. So it's extremely efficient, and the dynamics and the bidirectional natures. So we use the gRPC tunnel to send this the packets so that it doesn't really rely on the deployment mode or AP operational mode.
So what you're saying is that it's any Wave 2 access point, and in any mode?
Not really any. We still have one condition. Actually, we really wanted to remove any kind of a limitation, but at the moment, intelligent capture function runs on the 2K and 3K and 4K. It does not run on the 1K AP yet. So we are hearing the customer demand that a lot of customers like these features. They want to have their any Wave 2 AP, but right now we leverage the hardware capability of the Wave 2 because Wave 2 have all of the latest, greatest wireless Aeronet software, such as the FRAs and the clean air and multi-radios and all these advantages and hyperlocations, and it allows us to deliver the maximum efficiency without hurting the end user experience, such as just regular the data transmission or throughput. We don't want to introduce any hiccups on the normal operation just because we have a better analytic functionality. So that's why we choose the 2K and above as a platform to learn this functionality. And then there's a slight difference between the 2K and 3K and 4K, especially more like a 2 and 3K versus 4K. So a 4800 have a special radio called a third radio that has hyperlocation functionality, and the BLE radio, and the 4800 uses this third radio to do a full packet capture over the air. We know that there's a couple vendors, a couple solutions that can do packet capture at the Ethernet port level. But if we capture from the Ethernet port, we will lose a radio header. So then if we lose a radio header, how we can identify that the VoIP packet dropping is caused from wireless link or wired link? We have to have the ability to see not just at the port level of IP, but we have to have the ability to see the port at the layer 2, like a WMM packet, so that we can see that what causes my suboptimal experience of my VoIP. But that requires the 4800, and we use a special the hardware and the design that allow us to do the self-sniffing radio. So self-sniffing radio is the Cisco patent pending technology that we design and implemented in the 4800 third radio. So what it does is it uses the extra radio, then it continually hearing the packet transmissions and receiving. But you know that. Can you imagine that? Let's think about the situation where we are at kind of a concert hall. There's my rock stars playing the guitars, and there's a huge speakers going on. And if you whisper your friends that they're standing there next to you at jumpings, and if you're whispering him, do you think your friends can hear your voice very well?
Not a little.
Not even
not much, right? Yeah, because the outside of the sound is so overwhelming. I can't really talk to my neighborhood properly, because my voice is just covered by the Rogers the decibel audio from the speaker. Same things happen on when we try to capture the data transmission from the far away the client, and whereas the same radio receiver have to listen from the nearby radio that is sitting next to each other, right? Probably they will get the RSSI level of NEC 20, NEC 30 maybe, and at the same time I have to listen NEC 80, NEC 85, and usually the AP radio does not have that much of a wide range dynamics. So what we implement was a specialized hardware that allow us to do that. So that's why the 4800 third radio is different from the other radio. And there's other advantages of the self-sniffing hardware, because this radio have the encryption key of the end user, so that wherever the users travels or located, I can get the packet in completely decrypted fashion. Let me see if I have the slide here. So even if users roam between the one AP to other AP to next AP, every AP use a different channel, and sometimes the client jump between the 2.4 and 5 gig, we can still create the single packet capture. DNA stitch the multiple file into one packet, and then it decrypted all the encryption that happened over the air. So we don't need to carry around the laptop with the USB, with the USB half. Yesterday we need to do that and capture from 3-4 different radio. But you know what we'll get with all this extra hardware, with the $5,000 software? You will get the one packet capture with a completely encrypted. So what we can get is, okay, I can get some roaming event, but when I want to troubleshoot my VoIP problem, all encrypted, what we can do, right? But that problem is no more the case in the intelligent capture, because we capture from the multiple AP, decode it real time, stitch it real time, store it in real time, transmit it to DNAC in real time. By the way, this can be all done in on-demand fashion as well as a scheduled fashion. I actually have a demo. Sorry, Jason, I have too much things going on my side. Intelligent capture is simply, jaw-dropping functionality. We try to address almost every different types of a user workflow. Some user wants to have on-demand. Hey, I want to capture this client. Let's go in, client, click the detail, and let's start the packet capture. Or I have a case that, you know what, this user, I know that Jim may come, turn off office at like 6 a.m., but he might not, I don't know. So let's capture from, let's say that the 30 and 2018, and I want to capture from midnight, like at 1 a.m. So I'm sure that whenever he come early at office, then I will be able to capture that client, and I capture 2 hours, and then I can capture the specific user. Okay, this guy, I will use June, because June has been my problem. You know what? We just go over the Mario, right? So who was that? The Mario. I want to capture Mario too. So I capture June and Mario because we found these two clients being a bit of a problem, and then I save it. Then it's done. Then I can go back home. Yeah, then I can watch the football and I enjoy my football game, and I can watch my Netflix, and in the morning, typical day of life, then I will get all the data, all the capture that happens, that end user turn on. And it doesn't need to be in my local office. I can easily program anywhere in my office, from Seoul to San Jose to London, anywhere. Then the system, because AP proactively send this packet to DNAC. So what else we can do as automation manner, right?
That really is. That's a great demonstration. It's a great use case. I know I've been there before. I'm sure a lot of our listeners have been there before. Minsei, thank you so much for taking time out of your schedule to run us through this. My last question for you is, this has been really great. May we ask you back on the show sometime when there's more exciting stuff to show with Assurance?
Absolutely. I have a bit of a regret that I was not able to show entire intelligent packet capture. We have the functionality of a catalog of functionalities. These are some snippet of the intelligent capture functions. All these different bullet points and different screens and different use cases. I know that 1 hour is not enough. We probably need to have one more exciting session to go over the detailed use case by use case troubleshooting exercise.
Well, you know what? End of summer is really not that far away. Let's get it on the books. Minsei, thank you so much for your time.
Absolutely. Yeah. Thank you, Jason. Right. It's been a pleasure.
This has been a presentation of Cisco's Wireless Tuesday. Be sure to continue the conversation at ciscofullbars.com, and at the top, click on the CFB Spark community. There, you can connect with scores of like-minded wireless LAN professionals. Be sure to subscribe to the Wireless Tuesday podcast using your favorite podcast player, and stay up to date by subscribing to the Wireless Tuesday newsletter at wirelesstuesday.fm. We will see you next month for an exciting episode of Wireless Tuesday.